Okay, now we're going to talk about amplitude and loudness. This is some pretty interesting stuff. So, amplitude is the relative strength of a sound wave or how much change in pressure occurs, which visually, a representation of this you can see here. So here's a sound wave. Um, this is the amplitude right here. So this distance in the wave is basically saying how strong or how big is this wave, and the greater the amplitude, the louder the sound will be perceived. So smaller amplitude here, it's a quieter sound. Loudness is the human perception of amplitude. And so if you're going to have something really loud, like a bass drum or a Harley motorcycle or something like that, that's going to have, again, a greater amplitude here, as opposed to, a quiet conversation or something that's a smaller amplitude, quieter, and so it's perceived as less loudness. So again, the difference between these amplitude is simply that strength of the sound, or if you want to get more specific, how much change in pressure is occurring. And you could think of that too if you've ever been close to something like a bass drum on a drum set, or maybe a really loud stereo where it's a lot of bass. It's moving a lot of air. You can actually literally feel the air moving, and so that's a greater amplitude if it's turned up loud as opposed to something quiet. And so loudness then is just the human perception of that. We'll get into some of this later with frequency. Okay, so the unit of measurement when we're talking about how loud something is, or the amplitude of it, we're talking about decibels. So there are two different kinds of decibels here. There's decibel SPL, which is simply talking about the strength of a sound in terms of sound pressure levels, as compared to decibel, which is the loudness of a sound in terms of a level or a signal. So there's different application with these as far as if you're measuring sound perhaps in a more scientific sense as opposed to maybe for audio mixing or editing, things of that sort. And I just want to show you this chart here really quick, which is pretty interesting. This goes through and shows you what different decibels are really, some different examples of what different decibel levels are like. And so you can relate to most of these. So if you're at 0 dB, that's something you're probably not going to hear. Once you get up to 10 dB, it's very faint, something, as it says here, like a whisper or a rustle of leaves. As you keep moving up, you can see how this changes to faint sounds from 20 to 40 dB, moderately loud sounds at 40 to 60, and then we start getting loud once you're at 60 to 80. You'll see from 80 to 100 is where it's getting very loud. Things like a truck going by, loud street noise, a factory, stuff like that. To this is where it's really interesting. Once you're at 100 dB, that's where it's deafening. So you can actually start doing damage to your organs of hearing at this point. And if you've ever been to a really loud sports game or something, sometimes they're measuring these decibels, and it's up at over 100 decibels or something like that. That's extremely loud, and you're actually hurting your ears in the process. Up here at 120 and above, that's literal physical pain that's being caused. It says 100 feet to a jet aircraft, or you're 3 feet from a bass drum, or 3 feet from an auto horn or something like that. So it's a huge spectrum here. It shows about 0 to 130, these different decibels, and the perceived loudness that we have as we're looking at amplitude and the strength of different sounds.